Hello? Hello? Hello?
It sounds like science fiction, a machine that can translate an alien language. But the aliens aren't in space. They're already in your house. For years, we've joked about what our dogs are thinking. We've guessed, we've projected, we've assumed. But now artificial intelligence is doing something no human has ever done before. It's listening, really listening. By analyzing the pitch, frequency, and tiny acoustic patterns hidden in a bark, AI is building something that shouldn't exist. A working dog-to-human dictionary. And the first translations aren't just cute, they're unsettling. Because what's coming through isn't random noise or instinct, it's intelligence, emotional awareness, a level of understanding that suggests dogs don't just react to us, they study us. They know when we're scared, they know when we're lying. They may even understand our world better than we understand theirs. But this entire revolution didn't start in a billion-dollar lab or a Silicon Valley startup. It started somewhere much quieter, somewhere dusty, somewhere no one was paying attention. Before AI ever listened to a dog, someone spent decades listening to something much smaller, something that would quietly prove that animals are capable of complex, meaningful communication. And that discovery would change everything. It started with a sound most people never notice. Out on the open plains, prairie dogs fill the air with sharp, high-pitched squeaks. To human ears, it's background noise, repetitive, instinctive, easy to ignore. But biologist Dr. Kon Slobodchikov heard something different. Something in those squeaks didn't add up. Certain calls repeated in precise situations. Others shifted subtly depending on what was happening nearby. The patterns were too consistent to be instinct alone. Instead of studying dolphins or primates, Slobodchikov focused on a small rodent most people considered simple. For decades, he and his team recorded thousands of prairie dog calls, synchronizing audio with video to see exactly what triggered each sound. Back in the lab, they turned the recordings into sonograms, visual fingerprints of pitch, rhythm, and frequency. And then the patterns emerged. Prairie dogs weren't just signaling danger, they were signaling details. Different calls for hawks, coyotes, and humans. Different sounds depending on whether a predator moved fast or slow. Even the color of a person's shirt changed the warning call. A tall human walking down the same path produced a completely different vocalization than a short human. A blue shirt produced a different call than a yellow shirt. Instinct couldn't explain it. What the team discovered was a structured communication system with layers of meaning similar to how humans use descriptive language. To test it, they fed years of recordings into an early AI model. The system learned to associate specific sounds with real-world traits and situations. And it worked. For the first time, a machine could translate animal sounds into meaning. This wasn't just about prairie dogs, it was proof that complex communication isn't exclusive to humans. And if a small rodent could encode such detailed information into sound, then the animals that evolved alongside humans, hearing our voices every day for thousands of years, might be capable of something even more astonishing. Prairie dogs didn't matter because of who they mattered because they broke a rule. And once that rule fell, scientists knew exactly where to look next. Dogs didn't suddenly become interesting to scientists. They were always the obvious next step. For over 30,000 years, dogs have lived alongside humans. They learned our routines, our emotions, our voices. They adapted not just to our environments, but to us. And yet, for most of modern history, their vocalizations were dismissed as simple reactions. A bark meant noise, a whine meant need, a growl meant aggression, nothing more. But once AI proved that animal sounds could carry complex meaning, researchers began asking a different question. What if dogs weren't just making noise? What if they were communicating? Using modern machine learning, scientists fed AI thousands of dog vocalizations paired with real-world contexts: what the dog saw, who was present, what had just happened, how the humans nearby were behaving. Patterns began to emerge. A bark when a stranger approached didn't match a bark during play. Whines tied to separation sounded different from whines linked to pain or anticipation. Subtle pitch changes carried emotional weight that humans could never detect. The AI wasn't guessing, it was recognizing structure. Some models could identify whether a dog was excited, stressed, protective, or relaxed based solely on sound. In controlled tests, the AI often outperformed humans. And that's when the realization hit. Dogs weren't just reacting to the world around them. They were communicating within it, adjusting their sounds based on context, emotion, and the humans around them. Which meant something unsettling. Your dog may not just be barking at nothing. It may be responding to you in a way we're only now beginning to hear. And what scientists discovered next would push that idea even further. While one team was decoding barks, another group asked a deeper question. What was actually happening inside a dog's brain? Not behavior, not guesses, but real-time neurological activity. Neuroscientist Dr. Gregory Burns at Emory University wanted to know whether dogs loved us or simply tolerated us for food. For decades, the assumption was simple: dogs attach to humans because of survival needs. But Burns suspected something more. He turned to functional MRI, fMRI, the same technology used to study human thoughts and emotions. But there was a major challenge. fMRI machines are loud, confining, and require complete stillness. Even adults struggle. Dogs, it seemed, should panic. Instead of using restraints or sedation, Burns took a radical approach. He trained dogs to participate voluntarily, using positive reinforcement. No force, no pressure, just reward-based learning. The first dog was Burns' own terrier mix, Callie. The team built a full-scale replica of the MRI machine and trained her to climb inside, rest her chin on a support, and remain still while the machine roared. Other dogs from the community soon joined. All could leave at any time, yet all stayed. Once scanning began, researchers focused on the caudate nucleus, the brain's reward center. In humans, it activates when anticipating something deeply valued: food, money, love, connection. The experiment: show the dog two hand signals. One meant a treat was coming, the other meant praise from the owner. The results were remarkable. For most dogs, the reward center lit up equally for food and praise. To their brains, a good boy was neurologically as rewarding as a treat. For about 20%, praise triggered an even stronger response. These dogs valued affection over food. This was the first hard evidence that dogs don't just see us as providers, they see us as something emotional and meaningful. And the scans revealed something more. A clue that dogs may understand humans in ways we are only beginning to grasp. The deeper understanding revealed by the fMRI scans raised another fascinating question. How do dogs process the words we speak and the tone we use? Scientists tested this by having owners speak to their dogs inside the scanner. Sometimes they used familiar, meaningful words like "good boy" or "sit" in a positive tone. Other times, they used complete nonsense words, syllables with no meaning at all, but delivered in the same cheerful voice. The results were striking. The dog's brains processed the words themselves in the left hemisphere, the same region humans use for language. At the same time, the tone of voice was processed in the right hemisphere, which handles emotion. In other words, dogs don't just hear what we say, they hear how we say it. And they combine the two to understand intent. It got even more fascinating when the signals didn't match. A cheerful tone paired with stressed words, calm phrases layered over tension. The brain scans revealed that dogs noticed the conflict. Their minds registered a mismatch. happiness in tone, but stress in words or body cues. This meant that dogs aren't fooled by fake calm or forced cheerfulness. They sense when we're anxious, upset, or lying. And it's not just sound. Dogs also detect chemical signals humans release when stressed, angry, or afraid. Tiny traces of adrenaline and cortisol our bodies emit. Paired with what they see, hear, and smell, dogs can read multiple layers of information simultaneously. Your dog has been studying you this whole time, your voice, posture, scent, and expressions. They're not just intelligent, they're walking lie detectors. Once you realize that, it starts to explain behaviors you may have dismissed as odd. That sudden growl when nothing seems to be there, the stare at a corner, the hesitance or excitement at unexpected moments, it all takes on new meaning. Dogs aren't just reacting, they're interpreting, analyzing, and responding. And this understanding sets the stage for one of the most fascinating discoveries about how humans and dogs bond, something that goes far beyond words. If dogs can read our words, tone, and even chemical signals, it's easy to think of them as passive observers. But they're not. They are active participants in a relationship that stretches back thousands of years. And one of the clearest clues lies in their faces. Researchers at the University of Portsmouth in the UK compared modern dogs to their wild ancestors, the gray wolves. They expected to find changes in jaw structure, skull shape, or brain size. Instead, they discovered something subtle and revolutionary. Dogs have a tiny muscle above their inner eyebrow, completely absent in wolves. Its only function? To raise the inner corner of the eye, making their gaze look larger, sadder, and more infant-like. Puppy dog eyes weren't a coincidence. Over 30,000 years, dogs who could manipulate humans with expression were more likely to survive, gain protection, food, and companionship, and eventually become the animals we know today. Evolution had crafted a way to capture our attention and our care through a single, powerful expression. But the influence doesn't stop at expression. There's also chemistry. Scientists measured oxytocin, often called the love hormone, in both humans and dogs while they simply stared into each other's eyes. No petting, no talking, just looking. The results were astonishing. Humans' oxytocin levels surged by more than 300%. Dogs' levels jumped over 130%. And it wasn't one-sided. It was a feedback loop. Dog stares, human feels affection. Human stares back, dog feels affection. On and on, creating a self-perpetuating cycle of trust and bonding. This system is so effective that it may answer a question scientists have long pondered. Who really domesticated whom? For centuries, we thought we tamed dogs, but the evidence suggests something far more profound. Dogs may have tamed us, shaping our brains and behavior to ensure survival, care, and attention. Once you see the depth of this manipulation, the familiar gaze of your dog starts to feel intentional, a perfectly evolved tool designed to capture your heart and maintain a bond that lasts a lifetime. But the story doesn't end with eyes and hormones. Anyone who has owned a dog knows the scene. The middle of the night, your dog bolts upright, hackles raised, staring into a dark corner, barking furiously. You flip on the light, nothing, just an empty room. For years, humans chalked it up to imagination, shadows, or creaky houses, but now science suggests there may be more going on. Dogs live in a sensory world far beyond human perception. Their sense of smell is tens of thousands of times more acute than ours, allowing them to detect subtle chemical changes, fear, illness, or stress, invisible to humans. Their hearing reaches ultrasonic levels, picking up sounds from other animals, electronics, or environmental cues we cannot perceive. Maybe they're not barking at nothing. Maybe they're perceiving a hidden layer of reality, one we cannot see. Some researchers and even paranormal investigators propose that dogs can detect phenomena beyond our understanding of physics. Tiny shifts in the Earth's magnetic field, the first tremors of an earthquake, or subtle presences imperceptible to humans. Across cultures and centuries, dogs have long been seen as guardians of more than just homes. In ancient Egypt, Anubis, the god guiding souls to the afterlife, had the head of a dog. In Celtic and Norse traditions, spectral hounds watched over the boundaries between life and death. Is it coincidence that dogs are consistently linked to the unseen? Or did humans observe something real, something science is only beginning to understand? Dogs can sense more than we can, both physically and perhaps even spiritually. This perspective reframes the barking at nothing phenomenon. It may not be a quirk or anxiety. It could be an ancient, evolved behavior, a survival strategy honed over millennia. Your dog may not just be your protector in the physical sense, but a watchful guardian in ways we are only beginning to grasp. And while these ideas sound almost mythical, they have practical implications. Understanding what dogs are sensing could save lives, both human and animal, by helping us respond appropriately to behaviors we might otherwise dismiss. All of this, AI translation, brain scans, evolution, and supersenses sounds incredible, but it has a very real purpose. Every year, roughly 3 million cats and dogs in the United States are euthanized in shelters, not because they're sick, old, or unlovable, but because of behavior. Labeled aggressive, untrainable, or problematic, these animals are quietly removed from the world. And yet, for most of these dogs, there's a story beneath the behavior. A dog that bites might not be bad, it might be scared. A dog that growls might not be defiant, it might be in pain. A dog that lunges might not be cruel, it might feel cornered, threatened, or overwhelmed. Until now, humans have been missing the language these animals have been speaking all along. But AI translators, built on the lessons of prairie dogs and modern canine neuroscience, are beginning to change that. Imagine a shelter worker pointing a device at a frightened dog. Instead of labeling it aggressive, the AI analyzes barks, whines, and body language, saying, high probability of fear-based anxiety, indicators of joint pain or discomfort. Suddenly, it's not a bad dog anymore. It's a scared dog, a hurting dog, a dog that can learn, recover, and trust again. This isn't just about empathy, it's about saving lives. The AI doesn't translate full sentences, it gives context. A fearful dog can be trained safely. A dog in pain can see a vet before it lashes out. Misunderstood behaviors become actionable insight. When combined with what we've learned from brain scans, that dogs value praise and emotional connection as much as food, the evidence is clear. Dogs are sentient, emotional, and deeply attuned to us. They aren't objects, they're individuals with rich inner lives. For the first time, science is giving humans the tools to respond appropriately, to see the cause instead of punishing the effect, to finally communicate with them, even if only indirectly. And that raises a provocative thought. If AI can start to translate fear, joy, and stress in dogs, what could it mean for the millions of animals who are misunderstood, abandoned, or ignored every year? It may not just change how we understand dogs, it may change how we save them. After tens of thousands of years, dogs have been studying us as much as we've been studying them. They've evolved muscles, expressions, and behaviors to capture our attention. They've shaped our brain chemistry with the oxytocin loop. They've learned to read our tone, our words, our scent, and our emotions. For centuries, we assumed we were in control. But the evidence suggests something else entirely. Dogs didn't just become our companions. They engineered a bond that ensures we protect, nurture, and respond to them, biologically, emotionally, and chemically. And now, for the first time in history, we're finally learning to speak back. AI translators, brain scans, and decades of behavioral research are giving us a window into their minds. We're beginning to understand not just what they feel, but why they behave the way they do. It's not about turning barks into full sentences. It's about empathy, understanding, connection. It's about finally listening to what they've been trying to tell us for thousands of years. So the question is no longer, does my dog love me, or does it understand me? The real question is, if your dog could truly talk, are you ready to hear what it really thinks about you? Because once you listen, there's no going back. And what you discover may change everything you thought you knew about the animals we call our best friends.